Hello all, today in this video I'm going to provide details regarding CNN with a new optimizer. So previously we have worked with some other optimizers and also we are going to make a demo for that, and also we will make a comparison. For that, initially we are importing the libraries which are needed, and then we are just loading the data set, which is heart disease data set. This data set we downloaded from Kaggle. You can just give us heart disease data detection. Kaggle means you will get this data, and with this data is having nearly 13 entries. Among that, the first 13 first 12 entries we will be for 14 entries. Among that, the first 13 entries we are using as the x variable, and the last entry, that is the target variable, we are using as the y variable. Then we are getting the info of the data set. From that, you may get to know that the whole peak is the variable which is float type and all others are integers. And then we are describing our data set, and then we are checking whether our data set is having any null entries. If it is having any null entries, means we have to work with any pre-processing function. Then we are determining or displaying the heat map of the data set. So this is the heat map of the data set. Then we are determining variables like x and y. From this, you may notice that since the first 13 entries are used as the x variable, we are dropping the target one, and in the y variable we are using only the target variable. With the use of this x variable and y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training. And by use of the test split function, we are determining variables like x train, x test, y train and y test, and then we are using this standard vector to convert into vectors of the variables like x train and x test. Then we are getting the shape of this x train and y train. Why? Because we have to give the output dimension of this variable, so input dimension. So but CNN will accept only this three-dimensional variable, so we have to reshape our data set. So we are reshaping our data set. Previously this is the shape, original shape, and after reshaping we are getting this shape. This shape is only given to the CNN layers. So this is the CNN layer description. For every optimizers, the layer descriptions are same only. So first is the sequential layer, followed by the convolution layer, which is convolution 1D. In this, we have specified the filter size, kernel size, padding, activation, and input size as 13,1, which is this 13,1. Then we are giving the max pooling layer as pool size as 2, flattened layer, then dense layer with the output dimension as 128 and the activation as ReLU, followed by a dropout layer with the dropout rate of 0.5. Then the final dense layer. Since our work is a binary classification work, we are giving the output dimensions as 1. If it is a multi-class classification work, means we will give the output dimension as the number of classes specified. Then since binary classification work, mostly the activation will be sigmoid only. Then we are getting the summary of this layer. So this is the summary of this layer. Then here we are using the optimizer as out Adam, and for the best model the validation accuracy should be high when compared to the accuracy, but in this case the accuracy is high when compared to the validation accuracy. So we are taking some steps to make validation accuracy higher than the accuracy. The steps we have taken is, initially with the dropout rate we have given 0.5, but when coming to the next code, that is the next layer description, we are making this decreasing this dropout layer. We can also make some other parameters which we have described in the previous videos. So we have also displayed the classification report and made a definition for the confusion matrix, and this is the confusion matrix for CNN Adam. For the same CNN Adam, we have just reduced the dropout size. Previously, it will be 0.5. Now it is 0.1. And you may notice that in this case, the Adam optimizer is also Adam. In this case, you may notice that the accuracy is validation accuracy is high compared to this accuracy. So we have also displaying the class precision recall F1 square value, and also we have displayed the confusion matrix. And then we have worked with the SGD SGD optimizer. All the layer descriptions are same. Only the one thing differs is within the compile function, in the place of optimizer, we will be replacing as SGD. Then we are describing for 50 approaches, got the classification report, and also we have got the confusion matrix. Then we worked with the rmsprop optimizer. Here you may notice the only difference is the optimizer. The same we have displayed the values and the classification report, and also the confusion matrix. Then we are working here in this code, we have worked with adadelta. The only difference is optimizer we have given as adadelta, and it has worked for nearly 50 approaches, and you may notice the difference. We have also got the classification report. You may notice the accuracy is 64, and then we are displaying the confusion matrix of this matrix, and then we have called all the accuracy of the every optimizers within a single code, and we are now displaying. You may notice that Adam and SGD is more or less, sorry, RMS prop is showing some more or less better accuracy, but this ADA delta is less only. I think ADA delta is not plotted here. So in the next video, we will just plot it. Thank you.